So one less sister problem to complete problem set 4 here for you. This is on page 39, problem 50. It would be a sister to your assigned problem 49. And it sets up this little geometric figure, which is a circle described by x squared plus y squared equals 36, with a square inscribed. And the idea is to find the shaded area that I've got shaded in blue outside the inscribed square, but inside the circle. So I think you've done enough of these problems to recognize that what we're going to do is to find the area, which is the difference in the area in the circle minus the area of the square. Okay. And we can get pretty far down the line with that very quickly if we just say, you know, this is a square with side S. that makes both of these sides then are side S. That makes this point right here the point S2, S2, the ordered pair. And that makes the radius, if I now look at this little triangle right here, this is a little triangle that I'll pull outside, blow up a little bit, S over 2, S over 2. The radius then is equal to S squared all over 2 squared plus S squared all over 2 squared, square root of that quantity. So that hypotenuse then by the Pythagorean theorem is S squared all over 4 plus S squared all over 4, and then we're going to take the square root of that. So that is S squared over 2, take the square root of that, and you're going to find that the radius is S all over root 2. And now the radius is sort of a big deal because we can kind of quickly write down that the area of the circle is equal to pi r squared. The radius is S over root 2, and so the area of the circle is pi S squared all over 2. And of course the area of the square is just the length of the side squared. And the sides are S, it's just equal to S squared. And so what we're looking for is the difference between pi S squared all over 2 minus S squared. All right, easy enough. All we got to do is solve for S, and we'll do that right here. Because this point, S over 2, lies on the circle, which means that S over 2 quantity squared plus S over 2 quantity squared is equal to 36. And as I kind of work that out, I'll get S squared all over 4 plus S squared all over 4 is equal to 36. And multiplying through by 4, I'll get 2S squared is equal to 36 times 4 is 144. And then I'm going to just, I'm going to divide by 2 and get S squared is equal to 72. And that quantity is the quantity that we're looking for down here. Right? If I put S squared into this equation, I'm going to get that the area that we're looking for, circle minus square, is equal to pi over 2 times 72 minus 72, and maybe I'll write that as 36 pi minus 72. That's the answer.